Let's see MCQ number 1. A particle perform linear ascension starting from mean position. Its amplitude is A, capital E. Period is T. At the instant when the speed is half the maximum speed, displacement is. Now here they given one condition. The speed is half the maximum speed. This is very important sentence. And here they given speed is equal to half the maximum speed. Now we have to substitute the value. Speed is given by formula omega under root a square minus x square is equal to 1 by 2. Maximum speed is given by formula a omega. Now you cancel the common term, simplify the equation, you will get the answer for x. Now we cancel here omega from both the side. Now squaring both sides. A square minus x square is equal to a by 2 square. So we get here a square minus x square is equal to a square by 4. Now here a square minus a square by 4 is equal to x square. Now it is coming 4 minus 1, 3 a square by 4 is equal to x square. So we have to find out x. Then root 3. Root a square is a. Root 4 is 2 is equal to x. And this is the answer. You can see this in option number A. The answer for this MCQ is option A. Now we start the next one. MCQ number 2. MCQ number 2. A body of mass 1 kg. So mass is given. Performing linear ascension, its displacement x in centimeter at time t is given by x is equal to 6 sine 100 t plus pi by 4. Maximum kinetic energy of body is. So maximum kinetic energy is equal to 1 by 2 m v max square. So 1 by 2 m maximum velocity is given by formula a omega square. So let me substitute here the values. 1 by 2 1 by 2 m so how much is the m that we decide? So m is 1 kg, and this equation we have to compare with the standard form. X is equal to a sine omega t plus phi or alpha we can use. So here omega is 100. So 1 by 2 into 1 into a is 6 multiplied by omega is 100 square. So it is coming 1 by 2. 6 square is 36. 100 square is 10 raised to 4. So we get answer here. 36 by 2 is 18 into 10 raised to 4. Is in erg. Because everything, no, not in erg. Let me correct here the unit. Listen, here we have to convert everything in the same system that we are not done here. So we have to convert this. Mass is 1 kg. 1 kg means 1000 gram. so that I'm not converted. This X is already in CGS. So here we substitute 1000. 1000 means 10 raised to 3. So 10 raised to 3. So here we get 18 into 10 raised to 7. This is in erg because we use everything in CGS. So you know that 1 joule is 10 raised to 7 erg. And here you get 10 raised to 7 erg means the joule. So the answer we get 18 joule. Therefore, option D is the right answer for this question. MCQ number 3. Length of seconds pendulum. Seconds pendulum means pendulum with period 2 seconds. On surface of earth is 1 meter. Length of second pendulum on earth is 1 meter. Its length on the surface of moon should be. Acceleration due to gravity on moon is 1/6 of that on earth's surface. So here period is given by formula 2 pi under root L by G. If we substitute T is 2 for seconds pendulum, and if we simplify this equation, then we get 1 is equal to pi square L by G. So we get L is equal to length of the pendulum is equal to seconds pendulum is equal to G upon pi square. Okay. Now here on earth, the given G upon pi square is equal to 1 meter. It is given. On moon, we have to find out how much it is. How much is the length? Okay. On moon, L is equal to G upon pi square, but G on the moon is given 1/6 G on earth divided by pi square. So we can write 1/6 G by pi square. And this G by pi square is given, it is 1. So 1/6 multiplied by 1 is 1/6. So 1/6 is the answer for length on moon. Therefore, option A is the right option for this question. MCQ number 4. Two identical springs of constant K are connected first in series and then in parallel. A metal block of mass m is suspended from their combination. The ratio of their frequency of vertical oscillation will be in the ratio. Now let I tell you one thing here. The formula for period is 2 pi by omega. And everybody know that omega is under root k by m. So P is 2 pi in a root m by k. So frequency is 1 by period. So we get 1 upon 2 pi under root. Instead of m by k, it is k by m. This is expression for frequency. Now here, m is constant. Mass of the block is m. It is a fixed. Pi is a constant. So frequency proportional to square root of k. And you have to find out ratio of frequency. So ratio of frequency is frequency 1 divided by frequency 2 is equal to in a root k1 divided by k2. Now what is k1? Force constant for the first combination is k1. Now let I show you here for first combination. First combination is what? Series. Means here, so this is a support, this is the first spring, and this is second spring, and this is a block whose mass is m. Now here the constant, force constant is K, here the force constant is K. In second situation, this is the second situation. So where it is in parallel, means this is the support, this is the first spring, this is second spring, they are parallel and a block is attached, the same block whose mass is m. Now here again force constant K, here the force constant K. Now we can do one thing here. We consider the force constant in this case is K1. Okay, and here in this case is total force constant is K2. And then we have to substitute K1 and K2 in this formula. Now let I explain how we get. When two springs are in series, that time force constant is given by formula. Let I tell you, 1 by K is equal to 1 by K1 plus 1 by K2. This is the formula. You solve this and you will get force constant in this series combination. I will use here, instead of K1 and K2, I will use force constant in series divided by force constant in parallel. So here in series and here it is in parallel, that we have to substitute in this formula. Okay. Now I will solve this one. So both the force constant is K. So 1 by K plus 1 by K. We get 2 by K. It is 1 by Ks. So Ks is equal to K by 2. So this is the force constant for the first combination. Second combination, the force constant K in this parallel combination is K1 plus K2. So K1 is K, K2 is K. So K plus K is 2K. So we get this force constant is 2K. Now we substitute these values in a formula and we try to simplify it. So under root Ks is K by 2 and here it is 2K. Simply we can write F1 by F2 is equal to inner square root K by 2 multiplied by 1 upon 2K. So K get cancelled, we get 1 by 4 in a root. 1 by 4 means 1 by 2 is frequency ratio. Therefore, the answer for this question is 1 by 2. Ratio of the frequency is 1 by 2 and 1 by 2 is option B. Question number 5. Graph shows variation of displacement of particle performing SHM with time. You can see displacement versus time graph. Which of the following statement is correct from the graph? Now let me check the statement 1. Acceleration is maximum at time t. So you know that acceleration is given by formula omega square x. So when x is maximum, that time acceleration is maximum. And at t, you can see here, at t x is 0. So acceleration is 0. So this option is not coming right option. Next one, force is maximum at t 3t by 4. The force is equal to ma. Okay? This is the formula for force. And if acceleration is maximum at 3t by 4, then force is maximum. So force, maximum force is maximum acceleration, and maximum acceleration formula is omega square a. Or you know that this is acceleration. This is acceleration. When x is having a value a, that time acceleration is maximum. And you can see here at 3t by 4 means here. So here the value of x is a by 2. Sorry, it is equal to a minus a, means magnitude wise a. So here force is maximum here at 3t by 4. So this is the right answer for this MC. Now velocity, next one also we discuss velocity is 0 at t by 2. This is t by 2. This is the mean position. Listen, this is the mean position. Because at t by 2 x is 0. X is 0. X is 0 means velocity is maximum, not 0. So this is wrong. Kinetic energy equal to total energy. Kinetic energy is equal to total energy only when x is equal to a by root 2. When we learn the graph, that time we derive this. So t by 4, you can see here t by 4, x is equal to a. So kinetic energy and potential energy are not equal. So this option D is also wrong option. So correct option is option B. And it is force is maximum at 3t by 4. Now problem number 8. At what distance from the mean position is the speed of particle performing SHM half its maximum speed? Speed is half of the maximum speed. Let's see. And here they given the path length. Listen, when particle is performing SHM, so this is the main position. This is extreme. This is also extreme position. Here x is equal to 0, here x is equal to plus a, and here x is equal to minus. So this total distance is the path length. You know that this is a and this is a. So path length is 2a. It means that 2a is 10 centimeters. So a is 5 centimeter is the amplitude. Okay, you can see here the given. Now here the given condition, speed is half the maximum speed. So speed is equal to 1 by 2 Vmax. Now we substitute formula of V and formula of Vmax. Then we cancel the common term. Okay? So A is 5 here. Now we substitute common term. Means we substitute the formula of V here and Vmax, yeah, A omega. Okay? This divided by 2 as it is. Now you can cancel the common term and simplify this equation for x. Now here the omega get cancelled. After that we solve it for x and we get x is equal to root 3 by 2, which is similar to the MCQ number 1. Then root 3 by 2 is this 0.866 and this amplitude is 5. So we get displacement or distance is 4.33 centimeter. Question number 9 from exercise. In SI unit, the differential equation of SHM is d square x by dt square is equal to minus 36x. Find frequency and period. Let's see the solution of this equation. So this is a given and we compare this equation with the standard. So you know that standard differential form is d square x by dt square plus omega square x is equal to 0. This equation we can write like this. So by using that you can write omega is how much? Omega square. Omega square is 36. Omega square 36. So omega is root 36 means 6 radian per second. As you get omega, then period is 2 pi by omega and frequency is 1 by period. Two calculations you have to do. So this equation is the given equation and this is the standard form. We compare both the equation. After comparison, we get omega square is 36. It means that omega is 6 radian per second. Now we have to find out frequency. So omega is 2 pi f. So frequency is omega upon 2 pi. Now let me substitute omega and we solve this one. Omega is 6. So 6 upon 2 into this pi is 3.142. Then we get 6 upon 6.284. And this division is coming 0.9548 hertz. And this is the frequency. Now we have to find out period. Period is reciprocal of frequency. It is 1 upon 0.9548. Or you can write like this well. So this is also frequency. So 6.284 divided by 6 is the period. After solving this, we get period 1.047 second. This is period. Now question number 10 from exercise. A needle of sewing machine moves along a path of amplitude with a frequency 5 Hz. Find its acceleration 1 by 30 seconds after it has crossed the mean position. Means time is given. Now let me enlist all the given parameter. So these are the given. Means amplitude, frequency and time. And you have to find out acceleration. So you know that acceleration is what? Omega square x. This is the formula of acceleration. Now x is not given anywhere. But here they are given frequency. So we can write x is equal to a sine omega t. Now, a is given. Frequency is given. You can find out omega. So omega is 2 pi f. Okay. And time is given. So everything is given. Then you can substitute. Now let I explain here. I hope you understood the hint. Now let's see the detailed solution here. So here omega is 2 pi f and frequency is 5. So if we substitute f is 5, then we get omega 10 pi radian per second. Therefore, the magnitude of acceleration, you know that acceleration is omega square x, but x is not known. So we substitute x is a sine omega t. Then we substitute omega, then amplitude, as well as, so the steps are here. So we substitute here omega, amplitude, and this sine omega t. So a extra here. Then after solving this, we get 10 pi square sine pi by 3. 10 as